On Friday, we did this. And I know it's like you come back from, a weekend, it's like, boy, I'm not sure I remember what we did last week, right? So I just try to provide a little bit of a basis for that. Suppose you had the expression 2 to the 4th is equal to 16. And on Friday last week, we said that that is an exponential representation, and we wanted to turn that into a logarithmic representation. And we said that that is the same as log. Do you remember what we put for the base? 2. Put 2 for the base. Of the number 16, and that was equal to our exponent of 4. So that's what we did the other day, okay? And why are logarithms important? Well, here's one reason why logarithms are important. Suppose I had this equation for you. 8 to what power is equal to 400? Suppose that was the question. 8 to what power is 400? Now, I just gave this test in pre-calculus, and there were students who they took that 8 and they tried to subtract 8 from both sides. That does not work. I had other students, and this was more common, that students would divide 8 from both sides. That doesn't work either. Does everybody agree that if you had 8 plus x equals 400, that's when you subtract 8? Or if you have 8 times x equal to 400, that's where you divide by 8. So the question is, what do we do to get rid of the 8? And that's what I want to talk to you about today, is solving that type of equation. It's not too bad, but I want you to just think about this. 8 to the first is 8. What is 8 to the second?
64.
64. Anybody want to guess what 8 to the third is?
400.
It's 512. So does everybody agree that whatever x is, it has to be a number between 2 and 3? Probably closer to 3 because it's 512 is 400, okay? So we're going to figure out what that number is. And the way you figure it out is we're going to do this computation, log base 8 of 400. And the way that you do log base 8 of 400 is you do the log of 400 and you divide it by the log of 8. So what I need you to do is somehow on your calculator, I need you to do this. I'm going to show you how to do it on mine, and then need every single person here to verify that they can come up with the same decimal that I can. Because if you can't, that's going to be a big problem. I have the log of 400. I type that in. I close my parenthesis, and then I do divided by the log of 8. As I type that in, it gives me 2.88. And that's my result. You got that? Is yours going? So here's another way to do it. Okay, so as I see some people working, if you do the log of 400 and then just write that down, 2.602, and then after you write that down, then do the log of 8, write that down, and then if you divide both those results, 2.602 2 divided by 0.903. And I would encourage you to go out 3 decimal places to get something close. So you could do that as well. Let's see what you type in again. Log 400 parentheses divided by log 8 equals. There you go.
Oh, I took them.
You did? You got yours? Okay. You get yours?
No, you didn't.
You got yours?
Yeah.
Okay. Yours. Got your calculator?
Yeah, it's at the bottom.
All yours.
So how do we solve? Do you have an extra question? Thank you. I think you stated a little bit. Very good. Yeah, okay.
All right, let's check it out. So we are going to practice using that change of base formula right now. I want to calculate the log of 6, or log base 6 of 14. And so in order to compute that, I do the log of 14, and I divide it by the log of 6. I'm going to type it in. Log 14 divided by log of 6. And I get 1.472. I'm going to write out to 3 decimal places. The directions say to write out to 6. I'm not going to make you write out to 6, but write out to at least 3. See if you can compute letter B and C on your own.
We flipped it. It's supposed to be positive.
Very good? Okay, then that one skill can then help you solve these equations. Okay, so remember before we said that if you had x plus 8 is equal to 400, you would subtract 8 from both sides. Agreed?
Yes.
And if you had 8x is equal to 400, you would divide 8 from both sides. Agreed? So the question is, what do you do if you have 8 raised to the x is equal to 400? Okay? And what we do to get rid of the 8, you've never seen this before, but this is what happens. Logarithms and exponentials are inverse operations of each other. So if you want this 8 to go away, you do the log base 8 of both sides. And it's gone, and it leaves you with x. So if you have the log base a of a to the x, this goes away, leaving you with just x. And I know that that looks really, really strange, but that's how logarithms and exponentials work together. By the end of this lesson, it's going to make a lot of sense to you. So if you see log base 4 of 4 to the 5th, these cancel, and I'm left with 5. If I see log base 8 of 8 squared, what am I left with? 2. Log base 9 of 9 to the 1? 1. Log base e of e to the 5? 5. Now, I want to show you one thing. I made a point here. Do you remember what we said on Friday? Log base e is the same as natural log. So if these mean the same thing. So if you see natural log and e, those cancel, leaving you with just 5. Okay? All right? So let's do the last thing that we are now doing then for this unit. We want to solve some equations. We're not going to solve all these, but we'll do about 4, and then we'll go to the back side. Okay? 8 to the x is equal to 162. What number would x be? I don't know. I have to get rid of the 8. And in order to get rid of the 8, I don't subtract, I don't divide. I do the log base 8 of both sides. And on the left side, this disappears, leaving me with just x. Do you remember how we compute log base 8 of 162? We plug into our calculator, log of 162 divided by log of 8. Log 162 divided by log of 8. I'm going to write it out to 3 decimal places, 2.446. Very good. The next one, e to some power is equal to 2. I want e to go away. If I want e to go away, I don't subtract e, I don't multiply by e, I don't divide e. I have to do the natural log of both sides. Notice on the left side, I am left with simply x. On the right side, I don't have to do my change of base formula, as we call it, where you do log of 162 divided by log of 8. I have a button for natural log right on my calculator. I look at my calculator, I press natural log of 2, and I get 0.693. The next one, 17 to the x is 64. 17 to the x is 64. I want to get rid of 17. What do I do to get rid of the 17? Log base 17. Notice that log base 17 and 17 cancel. I'm left with x. And then on the right-hand side, log base 17 of 64. I take the log of 64, and I divide it by the log of 17. And I get 1.467. I'd like you to skip letter E, but please try D and F on your own. D and F on your own. We're okay with those? Okay. 4 more examples, we'll be done. I need to change letters B and D from what they are. I'll change them in a second here. But I'd like to start by solving problem A. It reads e to the 2x minus 3 is equal to 7. I want to get at the x. I'm going to have to move 3 things in this scenario. I'm going to have to move the e, the 2, and the 3. Okay? Before I can do anything with the 2 or the 3, the e has to go first. And the way I get rid of e in the denominator is I take the natural logarithm of both sides. So if you notice here, I'm going to write natural log on the left and natural log on the right. Notice that those reduce, and I'm left with just 2x minus 3. And then on the right-hand side, it says natural log of 7. So I'm going to go ahead and just compute that on my calculator. Natural log of 7, 1.945. And now you can solve your basic 2-step equation. We can add 3, we can divide by 2. .472. We're going to change letter B. I don't like letter B that I wrote up there. We're going to change it to 2 plus 5 to the x minus 3 is equal to 12. Anybody want to guess what I do first to solve this?
Minus 2.
Subtract by 2. I get 5 to the x minus 3 is equal to 10. I have 2 things I have to get rid of now. I have to get rid of the 5 and the minus 3. I get rid of the 5 first. How do I get rid of the 5? Log base 5. And we get x minus 3 is equal to log base 5 of 10. That I have to compute on my calculator using my change of base, which is log of 10 divided by the log of 5. 1.431. Finally, I'll add 3 over. I get x is equal to 4.431. Try letter C on your own. Try letter C on your own. I start by doing the log base 2 of both sides. I have a 2x minus 1 is equal to, we need the log base 2 of 46. And so I have the log of 46. I'm going to divide by the log of 2. I get 5.523. Hayden, did you make a mistake? It's okay. I was just hoping we could all learn from it. Never mind. Okay. All right. So once I compute that to a decimal, I can go ahead and add 1. I have 2x is equal to 6.523. And finally, divide both sides by 2. I have x is equal to 3 point. Anybody? 261. Okay, there we go. All right, I'm going to change problem D. This will be kind of our content limit, the hardest kind of problem that we would try in this situation. We have 6 minus 2e to the 4x plus 1 is equal to negative 194. And this is more of a state of mind than it is anything else. But, can you do difficult things? And I hope that you feel like you can. We're trying to teach you some things that are a little bit new to you. And it may look challenging, but we're going to make it look easy. Okay? First thing is the value of the 6 positive or negative? Positive. So even though you see subtraction, the value of the 6 is positive. So therefore, I will start by subtracting 6 from both sides. I'm left with a negative 2e to the 4x plus 1 is equal to negative 200. Now, before I get to the e, I need to get rid of negative 2. And if I get rid of negative 2 times, what do I do to both sides? I'm going to divide by negative 2. Very good. All right. Well, that looks like an equation that I can solve. How do I get rid of the base e? Natural log both sides. And I have the natural log of 100. I don't know what that is. I think it's about
4.605.
I subtract 1. I have 4x is equal to 3.605. And then I divide by 4. X is equal to 0.9. 0.1, I believe. Not too bad, huh?